For today's webinar, we're going to focus specifically on Junior, the benchtop solution that is configurable and customizable to fit the needs of each user. Junior is a modular benchtop size system that is capable of automating a task like sample processing, buffer exchange, buffer prep, or biologic formulation, or sample stressing such as heating or vortex mixing, or finally automating analytics. Today, we're going to largely focus on the ability of Junior to automate analytics workflows for biologic formulation and with Junior biologic configurations. So some examples of these Junior biologic configurations that I'm talking about. These configurations are for analysis of biologic formulations and can include various combinations of pH measurement, viscosity analysis, and visual inspection. Depending on what your needs are, Junior can be configured to automate pH measurement and viscosity analysis in a single biologic formulations workflow, or to automate pH measurements and visual inspection if that's more to your needs. Today, though, we're going to focus on a Junior configuration to automate both viscosity analysis and visual inspection in a single benchtop automation system. Each of these configurations shown, while they are configured in this way, can be customized to meet the needs of a user. For example, you could add things such as temperature control of samples on the deck for viscosity analysis or for storage of your samples at the right temperature. So looking more into detail on the configuration we're focused on today, Junior with a viscosity station and a visual inspection station, that is shown on your screen right now as an example configuration. So let's see how Junior works to accomplish these tasks. Starting with the arm elements, which are displayed at the top of that picture, the left arm element, labeled as number 1 in the configuration shown, is a flexible tool changer. This arm is used with a positive displacement tip tool or a PDT tool to use positive displacement tips for the viscosity station. While this arm element is used to inject samples into the viscosity station in this configuration, the flexible tool changer can also be used with a wide variety of positive displacement tip sizes for all liquid handling. It can also be used for powder dispensing or to crimp and decrimp vials. Moving on to the right side of the arm is the vial plate gripper, and that is labeled as number 2 in this image. The vial plate gripper does what it sounds like. It grips vials and plates to move them around the deck. The vial plate gripper can also be used to cap and decap vials with screw tops when used with a capping-decapping station on the deck, and we're going to talk a little bit more about that in a minute. So moving on to the deck elements. On the left side, labeled as number 3 in this image, is a viscosity station. This is a microcapillary-based viscometer that measures the viscosity of samples in a temperature-controlled environment. So the inside of that viscosity station is temperature-controlled to a user set value. The viscosity station has an automatic wash cycle that cleans the internal capillary between samples, and this helps to prevent cross-contamination during viscosity measurements. To the right of the viscosity station, labeled as number 4, is that positive displacement tip tool that I was talking about. This PDT tool works with the flexible tool changer arm, again labeled as number 1, to do liquid handling with positive displacement tips. In this case, the PDT tool is used with 100 microliter positive displacement tips to inject sample into the viscosity station at a controlled flow rate. These PDT tools, though, come in a wide range of sizes and can be used for a variety of liquid handling tasks. Next, we have the cooled storage bay, which is labeled as number 5 in this image. The cooled storage bay is a temperature-controlled vial and plate storage bay that will hold your samples at a constant temperature for analysis such as viscosity or for preservation during and after a run. And finally, on the right side of the Junior, labeled as number 6 in this image, is a visual inspection station. The visual inspection station uses image-based visual inspection to analyze the color, turbidity, and visible particle count of biologic samples in sealed vials. A deck element not pictured here that's useful in this configuration is the vial capper-decapper station that I mentioned. This vial capper decapper station is used with the vial plate gripper arm labeled as number 2 to remove and replace screw tops on vials. With this element, Junior is able to visually inspect samples in sealed vials and then remove the caps of these vials for viscosity analysis of the sample, and then recap the vials for storage with temperature control throughout the entire automated process. One of the first questions when considering protein formulation candidates is, can you develop it? If a protein formulation is too viscous to develop or to deliver to a patient at your desired concentration, there's not much use in pursuing it. The viscosity station on Junior is capable of automating viscosity analysis with quick measurements to answer the question of developability early.